Hello students, in this video we are going to study the process scheduling. So this is the very important topic. So what do you mean by process scheduling? So process, we know what is scheduling or process scheduling. Okay, so scheduling is nothing but whenever the processes are going to enter into our system, we have to schedule uh, them for the execution. So how we are going to schedule how we are going to make the schedule? By using the set of instructions and the mechanisms. So those mechanisms and the rules are going to give the order in which the process is going to be executed. So in simple way, the scheduling is nothing but we have to schedule, means which process is going to execute first and further on. Okay, so this is nothing but the process scheduling. Okay, so now what are the objectives of scheduling? So if after making the scheduling for the processes, so already we have defined which process is going to work first or which process is going to run second. So if you are advancedly you are doing this, it is going to make the system fast. So second is maximize the throughput. So maximize throughput is nothing but what, in a certain unit of time, the how much that process has been executed we can calculate. Okay, so that is nothing but it maximizes the throughput. Similarly, we can even maximize the number of interactive users within the response time. Okay, so there are the users are going to again running the various processes. So here we can maximize the number of interactive users in a response time. Okay, so now fourth is achieve a balance between response and utilization. Means what? Utilization means we are going to utilize the CPU in a very balanced way, and response time. So response time is what? Within a certain time or in how much fractions of second the process is going to be completed. That is nothing but the response time. So similarly, the resources are going to be used very balancedly. Okay, so now there are two main types of scheduling. Scheduling is mainly of two types. One is non-preemptive and the preemptive. So what do you mean by non-preemptive here? So in the non-preemptive scheduling, once a process enters into the running state, it completes its execution before the next process starts its execution. Okay, so in the non-preemptive scheduling, once a process are going to enter into the running state, it has to complete its whole execution before the next process is going to arrive for its execution. Clear? So second is preemptive. So in a preemptive, we can decide, in preemptive scheduling, once a process enters into the running state, it may or may not complete may or may not complete its execution before the next process starts its execution. Means what? When the OS decides to favor another process, the process is preempted during the execution. So in the operating system is going to decide, for suppose P1 has entered first for the running state, but due to the certain reason it has been blocked, and the next process is going to be run according to the permission of operating system, that is called as the preempted during the execution. We are going to stop that process P1 and immediately we are going to start the P2 for the execution. Clear? So this is non-preemptive and preemptive. So in non-preemptive, we are not going to stop here any processes execution in middle. Similarly, in preemptive, we can stop here. That is nothing but preempted during its execution. So next is, so for scheduling, we have to make here the queues. So there are three types of queues we are going to use here. One is job queue. So job queue is by default whenever all the processes are going to be entered into the system, all processes are going to be stored in the job queue. Clear? So whenever the processes are going to be are entered into the system, by default they all will be in a job queue. So similarly, a ready queue. Second queue is ready queue. So you can see processes which are in the ready state are to be put in ready queue or placed in the ready queue. So similarly in device queue. So when suppose if the process is waiting for a certain input output device, so in such processes are placed into the device queue. So these are the three main queues of scheduling, that is job queue, ready queue and device queue. Clear? So now there is one diagram how the processes are to be placed in the ready queue and the device queue. So by default, so here within a circle I have mentioned here the numeric numbers 1 to 7. So 1 is what here? So by default I told now that all the processes are to be placed in the job queue. So after in job queue, each job is going to be go for the ready queue. Okay. So now if this process is ready for the execution, those processes are to be placed in the ready queue. So now the CPU is going to execute the processes. If it completes its execution, there is no matter. So if in middle, if any interrupt occurs, so interrupt may be that process is requiring the input output request. So third circle indicates that if suppose that executed or the process which is executing, it needs certain input output request or input output, so those processes are to be placed in the device queue. So here I have mentioned input output queue. Okay, so after getting the input output, again it has to be go for the ready queue, and again it is going to execute for the CPU. So if no, there is time slice expired. So if for the execution, if certain time, suppose we are assigning the certain time for the processes, each processes, suppose P1 is executing for 2 milliseconds. So if that time expires, means what? Still we are still there is a it has to complete its executed, but because of time expire or time out, we have stopped the that current execution of that process. So again those processes are to be placed in the ready queue. Or one more is fork a child. So fork a child is what you can say the sub processes of a the sub processes of a processes are nothing but the fork a child. So again those sub processes are to be placed first, child executes, and again it is to be placed in the ready queue. And if an interrupt occurs, so again those processes are to be placed in the ready queue. So in ready queue, again the whole input output request, time slice, or it may be a sub processes, or it may be an interrupt. If all these conditions are going to be occur, so those once again we are going to store in the ready queue. So if without any interruption, if it is completing its execution, then no matter. Okay, so this is how the processes are going to be run in each queue. Okay, thank you.